In UniFi network controller, if you want to control the network communications, you have multiple options. For example, you can define firewall rules in settings, security, or you can create IP ACL rules also from the settings security. So just by looking at the UI, they look very similar. And in fact, their end results are also very similar. You may wonder what their differences are. So in this video, let's talk about it. First, let's talk about their technical implementations. In UniFi devices, firewall rules are implemented in the UniFi gateways by using IP tables functionality provided by Linux. And for IP ACL rules, they are implemented in UniFi switches. In my lab environment, for this testing UniFi gateway, UXG Pro, and a test switch do not have any custom firewall rules or IP ACL rules active. As you can see in the left side, yes, I have many dummy firewall rules, but they are all inactive. The ones you see now, they are the default firewall rules generated by the system automatically. And in the right side, I'm showing you the IP ACL rules, or the existing ones, they are disabled. So then in the lower part of the window, let me SSH to the gateway and to the switch. Okay, you can see from the initial screen of the SSH sessions, the two devices, they are running different operating systems. For UniFi Gateway, it's using a custom Linux based on Debian. For UniFi Switch, it's using BusyBox. It is an embedded Linux system. For the left side UniFi Gateway, let me show you how the default firewall rules are implemented. Let me run the IP tables command, show the details, and I only want to show you this particular chain because all of our LAN-in firewall rules are implemented in this particular chain. As you can see, there are already multiple rules existing and they correspond to the default firewall rules defined in UniFi network controller. For example, the very first one, what it is saying is it allows the network traffic from the .10 subnet, which means VLAN 10 in my lab environment. It allows VLAN 10 devices to access the network. Pretty straightforward. They are simply implemented using the built-in Linux IP tables. In the right side, go to the command line interface. Let me show the current IP access lists. There's nothing because we don't have a single IP ACL rule active now, right? So now you see the default situation. Then let me activate a dummy rule in both sides. Then let's see what's the change in backend. Okay, as you can see, for firewall rules, I enabled this one. It's a very simple rule. It will drop the packet if it's from this particular machine to this VLAN 20 machine. Okay, for the right side IP ACL rule, it will block if the packet is from this VLAN 10 machine to this VLAN 20 machine. So they are supposed to achieve almost the same effect. Then let's see how they are implemented respectively. So in the left side for UniFi Gateway, let me run the exact same command. Let's see what's the change in IP tables. Now you can see this particular new rule in IP tables. It applies to all the interfaces because this particular chain is for LAN-in, right? And our firewall rule is defined as LAN-in type. Then if the source is this VLAN 10 machine, destination is this VLAN 20 machine, it will drop. It's a very simple implementation. In the right side, let me list the current IP ACL lists. Okay, we have a list, global IP ACL. Now let's see what's the details. It simply says it applies to all the ports for this particular switch, and the action is deny if the source IP address is this one, the destination IP address is this one. It will deny the access. You also notice the second one, permit all. If you do not have this one, all your traffic will be denied. That's why at the end, you need one to permit all. That's how ACL rules work. So now you see the different implementations. And there's another thing I want to stress. In the left side, you can see for firewall rule, it applies to these different types: LAN in, LAN out, internet in, internet out, gas in, gas out. That's the granularity for your firewall rules. But for a ACL rule, if you just check the UI, you can see the granularity is per switch. So in my case, I have 2 switches. By default, it will be applied to both, but you can choose to only apply to selected ones. So it seems for IP ACL rule, the granularity is per switch. But if you check the backend, you can see, in fact, the backend CLI also supported. You can define the ACL rule per port or per interface. So you can have different ACL rules for different parts if you do it in backend. But for some reason, maybe Ubiquiti wants to simplify the UI. If you do it from the UI side, the granularity is per switch. By using ACL rule, you have more granular control. Ubiquiti's ACL rule implementation also has a limitation. It cannot be used for some specific switches. For example, in this environment, you can see some switches are grayed out. This is the UDM Pro. It also comes with simple switch. And for this cheap Flex Mini, it also doesn't support IP ACL. I believe it's simply due to the cost. They are too weak, so don't have the hardware to support the ACL functionality. Okay, now let's move on to the second difference we want to discuss. In this section, let's talk about performance or speed. Normally, ACL process traffic faster than firewall, but to most of us who use Ubiquiti, that tiny performance difference, if any, doesn't really mean anything. And in my lab environment, I don't really have the proper devices and the environment to measure the tiny performance difference. But just for fun, let me still do some testing to see whether I can even sense some difference. Before messing up with the rules, let me have a testing about the baseline performance. As you can see now, I don't have any custom firewall rules or any IP ACL rules activated. In the lower part of the screen, for the 2 Linux machines, let me ping from the VLAN 10 machine to the right side VLAN 20 machine. This is the command I'm going to run. I'm pinging the VLAN 20 machine. The interval is 0.1 second, not the default 1 second. And I want to ping 1000 times. At the end, I will take the average. So let me kick it off. Okay, it finished with this average time, 0.336. In the UX3 Pro, I created 24 dummy firewall rules. When I say dummy, I simply mean, yes, they are valid firewall rules, but it's just the IP addresses included in the rules. They are not really used by any devices, which means they are useless. But it doesn't mean they won't impact performance. Let me explain you what I mean. Let me activate all the 24 of them. Okay, I have 24 dummy firewall rules activated. Now if I go to the backend to show the IP tables, you can see there are many new rules created and they are corresponding to dummy rules. If you pay attention to the order of the rules, you can see they appear ahead of the built-in default firewall rules, just like what you can see from the UI. In the very last column, you can see the ID, right? They identify the order or sequence as well, which means during runtime, the Linux kernel will go through all the rules. For example, for the very first dummy rule, yes, it will check for the particular packet whether the source is this one, destination is this one. As I explained, these 2 IP addresses are not really used by any devices in my lab environment, which means every time the condition will not be met. But the system still need to spend time, resource on checking the conditions. Of course, it won't drop. And then it will continue, check another dummy one. It will use some system time and resource when any packet is processed. Okay, now let me repeat the ping operation from VLAN 10 machine. Let's see how it performs now. Okay, the average time is 0.341. Yes, a little bit longer than the previous testing where we didn't have any custom firewall rules, right? Then let me do the third measurement for the IP ACL rules. Of course, I need to disable all the firewall rules first. Okay, firewall rules disabled. Then move on to the IP ACL rule. Let me enable all the 24 dummy rules. I call them dummy IP ACL rules because they are valid rules, but the IP addresses used in the rules, they don't have corresponding devices, so they are useless. So now I already activated all the 24 of them. Let's see what's the current situation in the backend. Okay, so you can see a long list of ACL rules, totally 25 of them. So the first 24 correspond to the ones we created, and the very last one is the permit all rule. And the way the system will go through the rules is it will blindly go through them by the order. It will check for a packet whether the source and the destination IP addresses meet these conditions. Of course, the condition won't be met, but the system doesn't know that. The system will spend time on all the 24 of them, and then at the end it will permit it. So let's see, when we have these 24 dummy IP ACL rules activated, what the ping performance will be like. Run the same ping command from the VLAN 10 machine. Okay, now we get the result back. It's 0.339. Yes, it meets the theoretical expectation. Remember, when we don't have any firewall rules or IP ACL rules, the performance was 0.336. Now it's 339. And remember, for the 24 dummy firewall rules situation, it's 0.34 something, right? Yes, the IP ACL rules performance is a little bit better than the firewall rules in this particular not very scientific testing in my lab environment. But this tiny difference, in my opinion, doesn't mean anything. As I said at the beginning, this particular performance testing is just for fun. Okay, let's move on. Let's talk about an important feature which firewall rules have, but IP ACL rules don't. One of the most important differences between firewall rules and IP ACL rules is firewall rule is stateful, ACL rule is stateless. When we talk about state, in Linux world or in UniFi's case, we are talking about the Linux connection tracking state. I do have a dedicated video in my channel about connection tracking. So in this video, I will not touch the details, but if you go to a firewall rule under the advanced, if you switch on menu, you can see this match state option. By default, in auto mode, none of them is selected, which means the firewall rule doesn't care about state. But if you want, you can choose menu and then check the states you want. So this is for firewall rule, right? But if you go to a IP ACL rule, you won't have such state option. So that's why ACL rule is stateless, just to show you what's the difference and why the state is needed in some situations. Let's consider this scenario. So I have 4 VLANs, VLAN 10, 20, 30, and 40. And in VLAN 10, I have a web server. In VLAN 20, I have another web server. And then web clients are in VLAN 30 and in VLAN 40. In the initial step, I have the basic requirement. So I want to isolate VLAN 10 and VLAN 30. I want to isolate VLAN 20 and VLAN 40. Let's not worry about the web server access yet. Let's first achieve the network isolation. So then let's see, in the left side, I want to achieve it using firewall rules. And in the right side, I want to achieve it using ACL rules. Let's first achieve this step. As you can see in the UniFi network controller, I already created 2 firewall rules. The first one, drop VLAN 10 to VLAN 30. It's a very easy one. It's a drop from VLAN 10 to VLAN 30. And I didn't select any states. For the second rule, it's the other direction, drop 30 to 10. Right? So I have a pair of firewall rules created to achieve the network isolation. Just to validate it from the VLAN 10 machine, let me ping the VLAN 30. No, not pingable. And from VLAN 30, ping VLAN 10. No, not pingable. We achieved the goal for the left side to isolate the 2 networks. Then move on to the right side. I want to use ACL rules to achieve that. So I already created 2 ACL rules. The first one, block VLAN 20 to VLAN 40, very straightforward. And the second one is just for the other direction. So by using these 2 ACL rules, I achieve the network isolation between VLAN 20 and VLAN 40. We can easily validate it. First, from VLAN 20, ping VLAN 40, not pingable. And from VLAN 40, ping VLAN 20, not pingable. So we successfully finished this initial step, which is we want to isolate these 2 pairs of network, right? By using 2 different technologies. Left one by using firewall rules, the right one by using ACL rules. We are good with this one. Now move on to the web server access requirement. So what if, for example, in VLAN 10, I have this Linux machine hosting a web server. And for VLAN 30, I have this particular client. I want to enable the web server access. Remember, VLAN 10 and VLAN 30 are already isolated, right? But I want to have an exception to enable this green access. And similarly, for the right side, I want to enable this access. So let's see how or whether we can use the firewall rules and ACL rules to achieve the same goal. Let's see how we can use firewall rules to enable this requirement. In UniFi network controller, I already created 2 new rules. The first one, allow the VLAN 30 client machine to access the VLAN 10 web server. It's an extremely simplified firewall rule. I didn't restrict the protocol and the port number just to save time. This is the first rule, to allow the client to access the server. And here I simply select alter, didn't restrict the state. And then for the second allow rule, I allow the server to respond back to the client. Why this is needed? Because to complete the back and forth communications, the server also need to send something back to the client, right? So this particular firewall rule is also required. I defined in the same simplified way. I allow the communication from the server to the client. In the same way, I didn't specify the states. Another thing I need to mention is these 2 new firewall rules are put ahead of the previous 2 drop rules because they need to be processed first. Otherwise, the packet will always be dropped. So we defined the 2 new firewall rules. Let's validate whether it works in the VLAN 30 client. From this browser, let me visit the VLAN 10 web server. Okay, it's successful. I got the result back. Then move on to the right side ACL rule. I created 2 new allow rules. And for the first one, allow the VLAN 40 client to the VLAN 20 server. And the second rule is to allow the web server to respond back to the VLAN 40 client. In the similar way, the 2 allow rules need to appear before the 2 previous block rules. Okay, then let's validate whether it works. Visit the VLAN 20 web server. Okay, it works. It seems we have achieved our goals using 2 different approaches. They both work. We are done, right? Not yet. The reason is the rules we created are too wide, which give the servers unnecessary access to the client. Let me show you what I mean. Let's check the firewall rule. From the VLAN 10 to VLAN 30, it allows all the states from the server to the client. The side effect is all of a sudden the server is able to initiate the communications with the client. So let me ping the client from the server. See, it's pingable. We don't want that because the client need to be secured. The server shouldn't be able to directly connect to my client. So then how do we prevent that? It's very simple because we are using firewall rule, right? We simply enable the states and we say only when the server want to send a packet which is in the established or related states. Again, I won't explain the details. If you are interested, check the existing video in my channel. So let me apply changes. And I also want to modify the first one, allow client to server. I only want to enable these 3 states, apply changes. The changes are active. Let me validate them. So from the client, let me refresh. Let's see whether we can still access the web server. Yes, it is still accessible. Then from the server, let me ping the client. Okay, now it's not pingable. So this time we achieved our goal. Only the client can initiate the web visit to the server, not the other way. However, for the ACL rule situation, whether we can achieve the same goal, let's see. We do not have any state setting because ACL rules are not stateful, which means we have no way to limit the behavior for the server to initiate communication with the client. We can validate it from the server. Let me ping the client. Yes, it's pingable. So you may think, what if we disable the second rule? We don't allow the server to directly communicate with the client. Then of course this ping won't work, right? But at the same time, the client cannot get the response back from the server. Refresh it. See, it keeps refreshing. So even though the client can reach out to the server cannot answer. Okay, now you see the effect in action when it comes to stateful versus stateless. Okay, this ends the video. Thanks for watching.